Welcome back, students, to our Chemistry 1510 video notes. In this video, we're going to talk about temperature conversions. So there are three temperature units that we're going to be using. There is Celsius, there is Fahrenheit, and there is Kelvin. So Fahrenheit might be what you're used to if you grew up in the United States. If you didn't grow up in the United States, you're probably used to Celsius. If you've taken a whole bunch of science classes, then you might be aware of Kelvin. So what we're going to default to is usually Celsius and then also Kelvin, depending upon the topic that we're working in. So when we look at temperature, there are two equations that we're going to utilize to convert between units. This first equation that's listed here converts between temperature in Fahrenheit and temperature in Celsius. So let's walk through one of these problems. For this first problem, it says express 75 degrees Fahrenheit in degrees Celsius. Well, I'm going to rewrite my equation here where it says temperature in Fahrenheit is equivalent to 9/5 temperature in Celsius plus 32. Now, for laziness sake, am going to leave out all of the zeros, and I'm also going to leave out the degree Fahrenheit because that degree Fahrenheit just makes the units cancel because really there's units on this 9/5. The other thing is that significant figure-wise, there's actually two ways to solve this problem with significant figures. And so I think that the easiest way to go about it is to say that if you had a sig fig in the ones place, then your final answer should have a sig fig in the ones place. So then other than that, let's work on this problem. So I rewrote my equation and I'm going to plug in my 75 degrees. Then I am going to rewrite what I have here and talk about what's our first step. So if we discuss math here, right? Please excuse my dear Aunt Sally, your good old PEMDAS. Well, what do we do first? And because these two things are multiplied, your 9/5 and your degrees Celsius, then you need to think about how you're going to isolate TC. Are you going to isolate it by first dividing by 9/5, which is the same thing as multiplying by 5/9, or are you going to subtract 32? So we're going to subtract 32 because that is what math tells us to do. So we're going to have 75 minus 32 equals 9/5 TC. Well, now we need to get rid of that 9/5. I think the easiest way to do this is to multiply by the reciprocal, which is 5/9. That is 5/9. So let's multiply the reciprocal by both sides. That cancels out this part, and we are now left with 5/9. 75 minus 32 equals TC. So I would let you put that into your calculator and round to the ones place in order to get a final value for your temperature in degrees Celsius. I say I'm going to let you do that because my children stole my calculator and I don't know where it is. So you can go ahead and plug that into your calculator and get a final answer. Now, the great news is usually people have a better time going the other direction. So here we have 1,350 degrees Fahrenheit, and we want to take our Fahrenheit and turn it into degrees Celsius. So we're going to put in our, it's the same direction. So we're going to put in our number here and go through the same process. So just like we did before, we'll subtract 32 and rewrite what we have, right? 1,350 minus 32 equals 9/5 TC. Let's get TC alone by multiplying by the reciprocal. So you'll notice that I didn't even give you one where I have you take Celsius and convert it to Fahrenheit, because that's not the problem that students have issues with, right? Students have issues with remembering their algebra here. And so that's the one that I wanted to give time to. Now, again here, lack of calculator, you would go ahead and you would subtract your 32 from your 1,350 and then multiply that by 5/9 in order to get the correct answer. If you do it any other way, you're going to get a wrong answer, so don't do it a different way. Now, if you have a graphing calculator and you can write it just like this, where you put this part in parentheses in your graphing calculator, then you're fine. But if you have a scientific calculator, then you would want to make sure that you are putting it in properly, right? So 5/9 times the subtraction there. So let's look at our other conversion. Our other conversion is going to be between Kelvin and Celsius. So this one's nice and simple, straightforward. All right, our temperature in Kelvin is going to be equivalent to our temperature in Celsius, but we're going to add 273.15 degrees. So we can go back and forth here, right? We have our temperature in Kelvin. We want the temperature to be in Celsius. And so we're going to plug in our temperature in Kelvin that we're given. We're trying to get our temperature into Celsius. And so what do we need to do to get TC alone? Well, subtract from both sides. So here you should be able to employ your significant figure rules and go through this process to get a correct number of significant figures here. And that's going to be your TC. So you can do the same thing the other direction. You are given your temperature in Celsius, and you want to convert it to Kelvin. So you're searching for Kelvin. You plug in room temperature-ish, depending upon what you think room temperature should be. Everybody's a little bit different. And you add those together. So when you add these together, finally one that I don't need, I can do in my calculator of a brain. I am going to end up with 296.2 because sig fig wise, I have one significant figure here in the tenths place, and I also have one in the tenths place here. So each of my values have a significant figure in the tenths place, and so I should end in the tenths place. So why can't I have a final answer of 296.15? Why can't I do that? Well, because over here in the 23.0, where I'm highlighting in blue, you don't know what digit is there. And so you can't take an I don't know, add a 5 and be certain of what's left or what you've added together. It doesn't work that way. So you have to look at your two things that you're adding, and I like to write them on top of one another. I think it's easier this way. And you look to the rightmost and you say, you know what, that one's limiting me. I can only go to the tenths place here, and here I also have something in the tenths place, and so when I add these two together, I must only have something in the tenths place, not in the hundredths place. So significant figures can be pretty tricky, so keep working on them where you have opportunities to. As always, thank you for your attention. This is Katoni signing out.